So here everyone, we have a global time series analysis that we are doing. We'll download this dataset from here. These two dataset have been blended together, and for more information we'll go directly into this website. This first one is GISTEMP from the NASA dataset, and the second one is the global component of climate at glance. These two dataset have been blended together into one dataset, and for the more information we'll get into these websites. And first we'll download it, and we will get this file, and this will be available into zip file, and extract it here, and you will get the file into this folder, into data folder. So that CSV file we will import, and check the data. We have 3 columns, and GCAG and GISTEMP have been blended together, so that we will extract and that we will analyze. So go straight into that CSV file, and these are the data that is available to us. And we'll first have a look at what are the libraries, what are we are that path that we're going through. Scroll it down and we'll see that all the details available here that will go into this video. So first of all, we will import the libraries. So for that, just open import plotly.express, press shift tab, you will get plotly.express as ex. Second one is import plotly graph underscore obj. Yeah, this one. Yes. So just press enter, and as geo. Okay, so import pandas as pd. So these are the libraries available to us that we have some runtime warning that will not going to make a problem for us. Just read on again, and that error will gone. So importing the data first, so we have data set as annual underscore csv. So pd dot read underscore csv annual underscore csv. So these are the data that is available to us. We can directly see that df.head, what the data that is contained in it, and this we have. Now after that, we'll have a look at plotly, that what kind of feature that it will give, why I'm going to use it. For that, we will use figure is equal to ex dot line, and we have to give data frame first, and after that x is equal to that x-axis year, and on the y-axis we will give mean. So clearly you can see we have to give the 2 column, and after that figure dot show. It is built on a top of matplotlib, and just so after that just press enter. It will take some time, and it is giving you the data. That so it's a time series that plot that we have. So axis a year and mean. So why we are choosing it? Because it's very intuitive, it's very better. You can download it, and after just clicking download, go into the folder of download, and you can see that for a presentation point of view, you can also get the data here. So just there is so much features available on the palette. Just zoom in it, and you will have that you can just see what are the values after zooming in. So there are so many available option. One of the option is toggle spike line. So you just toggle it. Yes, it's enabled, and you can see the relationship between the x and y axis, so you can get from here. So yes, here, and you can compare the data when you hover your mouse onto it. So that will become more clear to you after some time. We will compare the data between the 2 data sets. Okay, so this is all about the plotly, and first we will do data wrangling. And for data wrangling, we'll just do some of that thing that we'll do here. So first we will do GCAG data frame. So we will try to segregate between all the data first, GCAG and GITEMP. So I want only the column which contain row which contain GCAG first, and I will extract the year and mean only from that. And after that, I will going to rename that particular year and mean that column name into whatever I want to do. So I will rename only the mean one. So in that column in curly braces mean, I will give the name to GCAG underscore mean. That's it. After that, just try to run it. So what generally it will give you, so we'll print the head command, and you'll see that it will give you all the data. Okay, so just copy, and again we will do the same thing for GISTMP dataset. So for the NASA data set, we'll do the same thing. We'll try to extract from DF that contains only GISTMP rows, and we'll try to rename the column to GISTMP underscore mean. And after that, we'll the thing that we need to check the index first, because index is ranging from 0 to only the even number, so that we don't want. That's why we are using index is equal to range length GCAG underscore DEF underscore data frame. So we'll do for this both the things, range length GISTMP underscore data frame. So just see that these are the indexes that if you don't want for concatenation purpose. So for concatenation we need the index to be in the range from 0 to up to n. So we'll try to print the head. As you see that index have been again rearranged. For GISTMP the result should be the same, and yes, so range is 0 to up to n. So that's we all want. After that, we'll try to visualize first the data with the help of Plotly. Before that, we want to concatenate, right? So I'll just, what I do is to okay, so I just yeah, okay, so I just want to insert one of the cell and try to mark it down as concatenation. So I actually forget it, so sorry for that. And concatenation, and just press escape and double M. It is a shortcut for concatenate, for markdown, and just press another cell command and you will get another cell. In this we will try to concatenate it. So df is equal to, we rename it df underscore final, yeah. So is equal to pd dot concat, that's function we will call, and after that we will have to give the object of two data frame. First is gcaag underscore data frame, and after that gist underscore data set frame, and we will concatenate x is equal to column y, that is, so x is equal to 1. So that will concatenate it. But the problem is that we have we only need 1 year and the mean of NASA dataset and GCAG. For that we will remove the year from one of that data frame. So after that to just reprint it, and yes, so the in that GISTMP the year we have deleted, and finally we print the head and concatenate it, and yes, so this is the final data set that we will be aiming for. And after that visualize the data with the help of Plotly. So rather than writing the full code, better is to copy and paste the code. So we will start from figure is equal to go dot figure. So that code we will reuse again and again, because 2 to 3 times we will gonna use that particular visualization. So go dot figure, into that we have to give layout, that we will first set what kind of layout we have, and in the layout we will set the x-axis, and x-axis is equal to, it will accept dictionary type of data structure. So it will type show grid that we want, grid, and title is equal to a year, and yes, and color is whatever you want to do. For example, I am giving it dark red, and yes, in the y-axis I will give another type of dictionary. I will mark true for show grid, and show grid is equal to true. Title is equal to y. Let's see, I've copy pasted both, same thing. Okay, so year is equal to temperature change. Yeah, so temperature change. And color is you can take any one. So my favorite is dark and blue. Okay, so dark blue. So that is the layout that we have set for our visualization. After that, figure dot a add underscore what is that function, a trace. Yeah, so figure dot add underscore trace and go dot scatter. So we use scatter plot, and plotly scatter generally it will plot the line plot just like a matplotlib, and x is equal to, in x-axis we will give we select df underscore final and gcag underscore mean, comma y is equal to, we also have to give y df underscore final, and we will give g. Okay, so there is a one problem that in access we want year, so we need to just change between the both of the values. So we will change the x to year. So here we will change, we will remove it, and dot year. Okay, so that is good. And after that we will write gcag underscore mean. Perfect, that will work fine. And after that, name, that we have to give it name, name for legend gcag underscore mean, so that we can differentiate it between all the plots. And after that, line color, we have to give the color of the line, so we will give it let's suppose green. Okay, so I will give it green. And after that, opacity, how much opacity it will have, 0.8, that is a vary from 0 to 1, that depending upon your choice. And we will close it, and there is something more okay, braces I have, that I will have to remove it. So remove the first, that will not going to make any problem. So that is, yeah, so we have checked it. Yeah, we remove it, and just copy paste all the thing from the first to only that figure dot add trace, copy it, and after paste it. Yeah, so it will work. And after that, rename it again to from gistemp underscore data frame underscore mean, and the year will be same, the because our data frame final have only 1 year, and the name is gistemp mean, and line color will be we have green, so we also have red option. So whom should we give? So the first one I will give red, second one is green, so you can do anything, that doesn't matter at all. And after that, we have to set the string. Now to update the string for the layout final, so I will write a command, use string to set start x-axis, yeah, x-axis, and after that range. So and I write figure fig is equal to fig dot update, that is a command underscore layout, and in it I have to give title text is equal to, and change in temperature. So that will work fine from 1880 to up to 2016. So that is the only we have. And after that, paper underscore bg color, so is equal to RGB A 233 comma 233 comma 233 comma 1, and after that plot underscore bg color is equal to, in this I will give RGB A 240 comma 230 comma 229 220 comma 1. So that is for plot background, and the first one is for you can give any value, that is up to you, and figure dot show. So that is all about we have, and we just need to check it everything is okay, so that final evaluation we can do and execute, and we have some error. We'll see that we have some module object is not callable. So what it's a problem, it's saying it's in third line. So in the third line the problem is it's okay, and yeah, so problem is L is capital here. So I think so it's only the error, and we can see, yeah, it's working. So you can see that this is the plot that we have, and the x-axis is here, and y-axis is temperature, and so yeah, we have set it, and this is the relationship between the two, and we could toggle the spike. You can see that whenever we hover our mouse over here, you can see that value, and that the compare toggle that I was talking about. Whenever you hover over your mouse, you can see both the values whenever you you see. So for the multiple plots in the single plot, it will be much helpful, and this is the value that range from 0 to up to certain values. And after that we will apply, there is a after we will apply some predictive model, and we plot the line. We will try to fit the line, and we'll see that after 2016 what could be the change in temperature rise. So if that thing is okay, we will try to fit the line. So we will try to apply predictive model from sklearn dot linear model. So sklearn and dot linear model import linear regression, and in it we'll try to set a value of x is equal to df underscore final dot iloc. We are slicing it, and all the rows and the column from 0 to 1 we have to give only the 0th value, but column value I'm giving it just for the cause that it x should be the data frame. gcag underscore y is equal to df underscore final dot iloc, and y should be 1 first value for gcag, and gistmp y is equal to df underscore final dot iloc all the rows 2. So this is the value that we are providing for xy, and we'll have another column, yeah, x value of x. So this is all the value of x we have, value of y. So gcag value of y, and we have, now we are going to do importing the model of linear regression and try to fit the data for gcag of y. So a given value of x, capital X, and gcag underscore y, and fit the model. Okay, so after fitting the model, we have fit the model, and we try to predict it. So we'll write predict underscore gcag is equal to model dot predict, yeah. So I am giving you value x, and after that I just try to see if I'm doing right. Predict underscore no, okay, yeah, this is the values for prediction by gcag after fitting the data. We'll do the same thing for GISTEMP. So model already we have the linear regression, so we'll use predict model dot fit. We have to fit the data first, x comma GISTEMP y. Yes, and we use predict underscore GIS TEMP, yeah, TEMP is equal to model dot predict x. So this will give me the value for prediction of GISTEMP. So I have prediction value of both the terms. so that we will gonna to use it and append it into our previous visualization, and we will see how the plot is going. So for that we'll copy paste this data and just paste it. Okay, so yeah, so we have here all the value. Just need to copy paste the only trace line and just paste it. The year will remain same, but the y will be different for the different prediction values. For prediction underscore GCAG, we will give y value, and the name accordingly we have to change, and the line color also, line color is equal to blue, and okay, so yeah, so name is equal to prediction, and yeah, the name is GCAG prediction, and that I will copy it and paste it. Again for GISTEMP, I will write prediction underscore GISTEMP, and the name will be GISTEMP underscore y. That underscore we have to remove it, and the color could be anything. Let's see, black. Okay, so I'll use black, and okay, so everything is all right. Yeah, so yeah, plot it, and after plotting will it will give me this this legend, and that data is varying from 1880 to up to 2016, and but the problem is that it's not giving us the accurate result, because you can see that it's not it's varying linearly, so our data is something different. So I'll try to predict some value with it, like prediction underscore GCAG underscore value, let's suppose, and uh, I can just write okay, so yeah, model. So we have already one models, we don't have different models. So for GISTEMP it will give me the model dot predict, and we need to give a value data frame, and 2100, the value is 1.11 degrees Celsius. So that is for 200 we have 1.8 degrees Celsius. Okay, so that is the value that provided to us by only GISTEMP model. So that's why the problem is that it's not varying that is varying linearly. We want to some different. For that we need to have some different idea. For that we are going to do in this cell, we use polynomial feature from sklearn that varying our data polynomially. For that, from sklearn dot pre-processing import polynomial features. Okay, so that will convert our data into polynomial, and underscore regression is equal to polynomial feature. In this we will give degree is equal to, let's say, 2. Okay, so after that x, we need to change or convert our x value into polynomial, and underscore poly underscore regression dot fit transform, and we have to give the value of x, and this is the x poly that we will always use for prediction, because it have been converted and transformed into polynomial. So poly underscore regression dot fit, we will fit the data with the help of x underscore poly with respect to some value GCAG underscore y, and after that linear under regression underscore 2, let's say, and is equal to linear regression, that is our model, and linear underscore regression underscore 2 is dot fit. We will fit the model, and with the help of x poly we will use it, x poly ly underscore comma GCAG underscore y. So hit it and we'll have linear regression, but that linear regression have a degree of 2. That is the main thing, and we'll try to have a prediction value. So first of all, we'll use poly regression dot fit. We'll try to fit that data for both the values GISTAMP as well as GCAG. So we'll use it, and after that linear regression, let's see 3 is equal to linear regression, and linear regression 3 dot fit the data for X poly comma GISTEMP. Yes, so it's giving me some error. Where is the error? Fit is not defined. Where is the problem? Okay, so that is the dot problem. Okay, so just hit enter again. It will give you the point. After that, we will extract some values that we will use it for our visualization, the prediction values. So for that, linear regression 2, we will try to do that, that we use it, and after that we will visualize it, and we'll finally get the data, how the data is varying. For that, we'll type prediction underscore poly underscore GCAG is equal to linear regression 2 dot predict and X underscore poly. That is the main difference, because we need to give the data polynomial. So just and after that, okay, so prediction underscore poly, that is for GISTEMP is equal to linear poly. Okay, so is equal to linear underscore regression 3 dot predict, we have X underscore poly. So that is all right. Okay, so yeah, so we have two values also, and we need to visualize it, and we have also the data. So let's see how the visualization is going on. For that, we will just copy paste the values or the text here, and just go into this cell and paste it here. We just have to replace the texts. Previously we have written prediction GCAG, so for that we need to insert poly. Okay, and after that prediction underscore poly GISTEMP. Okay, so we need to also give the legend name to different poly, and the legend name is polynomial. Okay, so all right, we have the data here, everything is all right, and after executing it, so this will give me the range, that is polynomial features. So the basic aim is to that after executing it, it will give me this type of plot, that accuracy will be somewhat better, that it will fit the data over all that that input values. Okay, so we can also change the degree to up to 3. So just change that, if the degree is changed, how much the accuracy or the graph will get changed. So graph will remain somewhat same, so it's not giving me a huge type of thing. So just hover over our mouse and see the values for 2014, how much spike or change for GISTEMP and GCAG, and similarly all the values from 1882 up to 2000. So this is the values that I will get. So yeah, after that we will just try to predict that using this value, this polynomial features from temperature and year, what could be the prediction values. Okay, so let me write from here. Okay, so temp underscore rise. Okay, let's see, I need rise linear regression 2 dot predict, and I will give into poly underscore regression dot fit transform. We need to transform it again. and in this we will give an n-dimensional array of 2030, and also I will give temperature rise of so better is that we'll try to rename in such a way that we can identify it, so that yes, it's GCAG. Okay, so I will write GCAG, and in it I will write TMP, copy and just paste it down near, and I will write GISTMP is equal to linear regression 3 for GISTMP dot predict poly underscore regression dot fit transform, and n-dimensional array you have to give, we'll assign some value of 2030. So at 2030, what could be the temperature? We will print the values. The temperature rise or change from temp from GCAG. Okay, so in GCAG that will be much better. GCAG is I will give you some value, comma, and GISTEMP is braces, and I will give format. Okay, so I'll write format, and I will give the value of here temp underscore rise underscore GCAG, comma, yes, for the both values GCAG, and it's give me some error. Where is the error that we are getting? And we have some problem like the temperature, yeah, the second one line, yeah. So here is our problem, that we haven't give here that okay, opening and closing. So that is the main problem. So our temperature rise in 2030 is 1.091, and for GISTMP our temperature rise is 1.475005. So I can also write it poly, but I will not, because both are the same, you can do the same thing. Okay, so this is generally for polynomial, and after that 2050 and 2050 I will give the value here. It will give me temperature rise in GCAG is 1.62. I'll also can change some different values. For example, let's see 2100, what could be the temperature rise? It will give me 3.5 and 3.97, and for 2150 or 2150 it will give me 6.43, 7.42. It's very much higher, guys. So that's why the temperature rise is increasing. And that's all from my side, and this is all the thing that you need to do to analyze it. So thank you so much for having me here,